Okay, hi there, Avian Science. It looks like most of you are confident that you, or at least think you found the lizard. It's right there. So I guess this one was on, oh, somebody says, nope, that wasn't where they spotted it. Okay. Here I am thinking that everybody's saying, I think I found it. Oh, several people saying they were wrong. Okay, good. That means it wasn't too easy. It was just about right. Okay. All right, announcements. There will be a regular links quiz and a regular, oops, I say review here. That should just be regular short answer questions posted on Friday. That'll be due on March 3rd. And I want to remind you guys to think about the project. You have to request a topic and how you are going to present the information that you uncover. Are you going to do a paper or a presentation or a TikTok video or whatever kind of format that you would like to do? I encourage you to be creative in the types of formats. It's more fun for me when I get a few odd things in there. Odd things that aren't just papers. But those requests are due a month from this Friday, on Friday, March 24th. You need to submit your requests on Blackboard. Once you've submitted them on there, I will give you a grade. It doesn't count for anything. A grade of 1 means everything's approved. A grade of 0.5 means I made a comment that you need to read. A grade of 0 means somebody else has already picked that particular animal. I don't have the list of topics that are already taken up in front of me right now, so I can't confirm or deny topics at this point. All right, so we've been working on the internal system of the birds, the internal anatomy. And we've talked about how they have an extra large heart, which is modification for flight. And we've talked about some skeletal modifications for flight. And we've talked about their respiratory modifications. That one-way respiration, which makes it so much more efficient than our respiration. Does anybody have any questions on that? I know the one-way respiration can be kind of strange.
So they inhale, it goes to those sacs, right? And then they exhale, or is that?
Yes, it's kind of strange. They inhale, let's call this, Kinley, I see your hand up. Did you want to jump in here or go ahead?
Yeah, so what I remember is they inhale the oxygen, it goes around in the sacs to get the oxygen clean, and then it goes out another way. Out of their nose or something.
That was well put.
Okay, let's see. I'm going to go to the whiteboard real quick. So I'm going to call these units of air. So the first unit of air is inhaled. So that's inhalation 1. Oh, come on. This goes to the posterior air sacs. So those are the air sacs that are behind the lungs. In exhalation 1, that unit of air goes through the lungs. Hang on, wait a minute. Yes, goes through the lungs. Gas exchange occurs. And they go into the anterior air sacs. No, that's just the exhalation. They're going across the lungs. Sorry. Inhalation 2, that original unit of air goes into the anterior air sacs. And exhalation 2, that unit of air goes out. It's out of the body. So while we have inhalation 2 and the air is moving into the anterior air sacs, at the same time, you're bringing in another unit of air. So another bit of air is coming in while the first breath of air is going into the anterior air sacs. So the air sacs both fill during inhalation and empty during exhalation. Yes, Ronit, it's like when you sing a song as a round where everybody starts off, or somebody starts off and then somebody else joins in at the beginning again, kind of a couple of lines or a couple of words later. Yep. Gosh, I haven't done that since Girl Scouts. It's been a while. Is that making sense to you guys? Maybe? Okay, good. Yes, I'm getting yeses. I like that. I like getting a response, even if they're no's. Okay. And a maybe. Okay, that's fair. You can watch, there are lots of videos that go through the process on YouTube. Sometimes it helps to have a different person saying the same information. Okay, we're going to move on to the digestive system. So, birds don't have teeth. So they're not able to chew food the way we do. You know, we spend a lot of time with the food in our mouth, grinding it up with our teeth. Since birds can't do that, they're going to be swallowing larger food items. And so to compensate for not being able to break it down into little pieces, they have a larger esophagus. So the esophagus is the tube from the mouth into the digestive tract. And I always have to look at spelling for this one. Esophagus. There we go. So it's bigger around than those in mammals. It is possible, just like it is in mammals, for birds to swallow something that's too large that they can't get down, and they can sometimes choke to death. It happens. But that's the process there. So that's the That's the first couple of modifications that birds have that you don't see in other, in mammals in particular. Hang on, I'm thinking about sneezing. Nope, apparently not going to do it. All right. The next thing that birds have that we don't see in mammals is a crop. A crop is a sac or pouch. Sometimes they're paired, sometimes it's a single one that acts as a temporary food storage location. We can see this hawk has a full crop right here, this swelling, that's normal. This young parrot of some sort also has food in their crop. Again, that is normal. He's just been fed. The food gets diverted to the crop, and then the crop will send little bits of the food to the stomach later. This allows the bird to either eat a large amount of food at one time, like hawks, generally speaking, they're going to be eating a whole mouse or half a squirrel or something. Kinley, I see your hand up. Go ahead.
So is a crop just a pouch in their throat? The definition?
Basically, yes. Okay, so birds that have to eat large amounts at one time. Other birds will fill a crop and go somewhere else to slowly digest in a spot that's a little protected from predators or from weather, so they can slowly digest it later on. When we're talking about hand-raising baby birds, the species that have a crop are much, much easier to hand rear. Finches and canaries, remember, they might need to be fed every 15 minutes when they're first hatched. Parrots and doves or pigeons might only need to be fed every 2 to 3 hours. So that's a significant difference right there. If you've got a baby bird that uses a crop, you need to monitor and make sure the crop is fully empty between feedings. The crop can get infections. There can be problems with it that cause something called sour crop, where the food isn't getting moved into the stomach correctly, and it's basically filling with bacteria and causing a nasty little infection right there in the crop. So if a bird doesn't seem to be emptying the crop, that's a veterinary event. Adult parrots, adult doves, and pigeons. Wild doves will often binge so that they get a full crop, but a lot of these adult parrots will not do that, especially in captivity. In pigeons and doves, the crop is also a source of something called crop milk. Just like we produce a liquid, highly nutritious food to feed our babies, pigeons and doves do the same thing. They produce this milk, this secretion in the crop, and then the babies stick their beaks down in mom's throat or dad's throat to get to the crop and suck up that liquid. So it's a food source for the babies. Okay. So, Ronit, yes.
Does that crop milk have any immune boosting functions the way it can in mammals?
I think so, but I'm not 100% sure. I'm like 80% sure. Other types of animals also produce a milk. There are fish that produce secretions for their offspring. Cockroaches produce secretions to feed their offspring. So milk is not, we used to say milk is what makes mammals mammals, but we're not that special. Okay, so this is a nice image of the digestive system in a chicken. Here's our esophagus. There's a crop, so chickens have a crop as well. And then there's this structure, proventriculus. I'm not going to ask you that word. I'm going to give you a different word for that part. And gizzard. Those are the next sections we're going to talk about. So what's labeled as a proventriculus is what can also be called a glandular stomach. And the gizzard is a second stomach. So these two are the two types of stomachs that birds have. The glandular stomach secretes things like digestive enzymes to help chemically break down the food. The gizzard is the muscular stomach. And it's amazing to see these when you do a dissection on a bird, because they're very thick-walled, lots of muscles involved, and those grind food into small pieces. Sometimes you'll find little stones there. People sell grit for domestic birds, thinking that they need the stones. In captivity, they really don't, and they can overindulge in eating the stones. So we don't want to offer those things. So what happens with these two stomach systems is the food moves between these two structures. And the glandular stomach secretes chemicals to break up the food. The gizzard grinds them up, and they just kind of go back and forth until the pieces are small enough to pass into the small intestines. Well, this chicken makes it look like they're just basically one structure. If you do a dissection or a necropsy on a bird, they are distinctly different structures. They have different textures, they're different sizes. So the small intestine is right here in the kind of in the center. And this is where the digestive process finishes and the absorption of nutrients and vitamins begins. It's a little bigger than is seen on this particular bird. And these structures tend to be further up in the bird, not quite down here. So this is a nice drawing because it shows all the parts, but it's not completely accurate. So what happens in the small intestine is very similar to what happens in mammal small intestines like ours. They use the same collection of chemicals, these enzymes, to help break things down. They start taking up the nutrients. Then the food, or what's left of the food, goes into the large intestine. The large intestine is wider around than the small intestine, and in most animals, it's shorter in length than the small intestine. So the large intestine primarily absorbs water. That's its job. And then it empties what's left, the feces, into the cloaca. The cloaca is a expanded structure, a tube that serves as a common opening to the digestive system, the urinary system, and the reproductive system. So we get feces stored here. We get urates from the urinary system, the white part of bird droppings. Sperm comes out of here in the males, goes in here into the females. This is also where the eggs are laid from. So everything goes out the cloaca. All right. Any quick questions here? Yes, a lot of functions. Absolutely. So that's kind of the course of the digestive system. I want to give you some fun facts about the digestive system. So I like turkey vultures. I love this cartoon. They stink, but they're amazing birds. And this cartoon tells you a lot of the stuff, like my head is bare to prevent rotting flesh from adhering to it. I poop on my legs and feet to keep cool. My main defense is vomiting. It's not projectile vomiting, but it's vomiting. It is true. Vomiting is the turkey vulture's superpower. And it is one of the nastiest things I have ever smelled. So when I list the nastiest things I have ever smelled, a well-rotted dead raccoon is number one. Turkey vulture vomit is number two, and skunk spray is number three. So I may be weird in not putting skunk spray higher up, but it's nasty. When I was doing wildlife rehab, I had a turkey vulture vomit on me. And that is the only time I have had to put the bird back in the cage and leave the room. But I had to walk out of the room and wash that stuff off immediately because it was truly disgusting. Other fun things. Bird intestines can shrink and grow. So at the beginning of migration, or in the early part of migration, the intestines will basically be broken down and absorbed for nutrients. When the bird reaches its destination at the end of migration and it's got food available again, it grows that intestine again. Raptors can tear food. Owls cannot tear their food. So they swallow it whole, and that's why they have to regurgitate or throw up. It's not really throwing up, but the same kind of idea there. The fur and the bones into an owl pellet. If you've never seen an owl pellet, they're pretty cool. It's just fur and bones. And if you're lucky and you break it apart, you can basically reassemble the whole rodent that they ate, the skeletal system of the rodent. Vultures also have, they don't poop out the bones and fur. It comes out the front end. How long did the clothes have to sit in OxyClean? If I remember correctly, most of the vomit was in my hands. Somebody else was holding the bird and I was trying to pill it. And it vomited on my hands. I think some got on my shirt, and I'm pretty sure I just threw the shirt out when I went home. You don't wear nice clothes to wildlife rehab. Okay. So the next system we're going to talk about is the reproductive system. And before we get into the reproductive system, I wanted to talk about albatross, and it's related to reproduction. So here we are, just some fun stories here. This albatross right here, her name is Wisdom. She is currently either 71 or 72 years old. She is the oldest banded wild bird. The last time she had a chick hatch was in February of 21. So that was 2 years ago, when she was 69 or 70. She is a very successful breeder. We believe that she has raised between 30 and 40 chicks to the point where they're capable of living on their own. She was seen on the breeding ground last fall, but she left without nesting. Albatrosses are monogamous, and Wisdom's mate did not show up on the breeding ground in the fall of 21 or last fall during breeding season. So since her long-term mate isn't around, she's not breeding. Now, when I say albatrosses are monogamous, I mean they're monogamous like people are monogamous, which means they may stick with the same partner their entire life, or they may get divorced and find somebody else. Or if their mate passes on, like we think Wisdom's mate has done, sometimes they'll find a new partner. The same species of albatross that nests, they nest all over the Pacific Ocean, various islands on the Pacific and Atlantic Ocean. And one species has several nesting locations. They breed in colonies on islands. And these locations that are in Hawaii tend to have a shortage of males. So it takes 2 adult albatross to raise a chick. They cannot raise 2 chicks. They cannot raise one on their own. So when there aren't enough males around at these particular locations in Hawaii that have been studied, up to 1/3 of the nests are 2 females. These female-female pairs, one of the females will go off and mate with a male and come back and lay an egg. Usually just one. On rare occasions, both of them will go off and mate and they'll lay 2 eggs, but they can only raise 1 chick and only 1 chick will survive. And this picture is to show you how big that albatross is. So this is probably an average size adult human male. This particular island, I think it's close to New Zealand. They monitor the breeding of the albatross on this island. And so they come out and check on the chicks periodically, make sure they're growing, make sure they're healthy. If they're not growing at the right rate, if they're not healthy, then they'll take them in and hand rear them. They don't want to do that, but albatross, like most wild animals, are in serious decline and could use a little bit of extra help. Okay. All right. So when we talk about the female reproductive system in birds, generally speaking, female birds have 1 ovary. And so this would be the area where the ovary is. The 1 ovary is capable of producing multiple eggs within a relatively short period of time during breeding season. So birds can, depending on the species, lay eggs every 1 to 3 days. In the ovary, these structures form called follicles. And each one of these follicles is one cell that becomes the ovum or ova. So there's one of these cells. And the rest of the follicle is made up of cells that produce egg yolk. So you can see there's a lot of blood flow, blood supply attached to these follicles, and all of this yellow stuff is egg yolk. These start to form during the breeding season. Yolk, of course, is the nutrition that will feed the developing chick in the egg. So this is the chick's food supply right here. One follicle at a time gets released from the ovary and goes into the oviduct. I think they call it something weird here, but we're going to use oviduct. If it gets fertilized, it has to be in the right part of the oviduct for this to happen. This can happen either because the bird has mated right then, or some species can store sperm. So they can be mated and then release sperm from a side pouch into the oviduct when they ovulate or release a follicle. So if it's fertilized, it moves along the oviduct and various other structures start to form. Some of these are produced by the oviduct and some are produced from that fertilized ovum or the yolk cells. So we start to get the production of white, the white part of the cells. That's the albumin. Albumin is a source of water for the developing chick and also a cushion to protect the developing chick. Then this albumin with the yolk move further along. There are several more membranes produced. These membranes are important for things like gas exchange between the chick and the outside environment, storage of waste material, and some other things. And at last, the shell is put on. This is the slowest part of the process. And this, the shell is made of calcium carbonate. It is permeable to air and moisture. So the chick can breathe air by breathing through the eggshell. But if you put the egg in water, the chick drowns, essentially. Somewhere on the internet, some idiot has posted that if you find a wild bird egg, you should put it in warm water to keep it warm while taking it to rehab. But don't do that. Don't do that. Not a good idea. So that's the basic female reproductive tract. Now let's talk about the males. Okay, so when it comes to male birds, oh, somebody knows what the next slide's about. We're going to talk about not ducks right now, okay? In general, male birds have two testes. They are completely internal. So in humans and most mammals, the testes are external. And they're external because sperm development requires slightly lower temperatures than our internal body temperature. Now we know birds have a higher body temperature than we do, but they're still able to produce sperm with internal testes. So there are genetic differences that allow sperm to develop at higher temperature in these guys. Usually these internal testes, one is larger than the other. In both males and females, these structures shrink outside of the breeding season and get larger during the breeding season. Sperm is produced in the testes, moves along specialized ducts to the cloaca. The male will press his cloaca against the female's cloaca and inject sperm. The vast majority of bird species do not have a penis. It just, the cloaca goes to the cloaca. This is called a cloacal kiss. And then there are ducks. All right, so waterfowl, oops. Ducks, swans, geese, and the ratites, the ostrich, the emu, the cassowary, yeah, they do have penises. And there's a huge range of size and shape in bird penises. So the ostrich penis is conical, duck penises tend to form this spiral shape. If you start looking at animal penises, human penises are boring. Am I going to ask on the quiz what birds have penises? Oh, yeah, quite probably, yeah. You're also not likely to forget this fact. Sometimes the penis is feathered. Sometimes it has spines and filaments sticking out the sides. Sometimes, like this guy, has little bumps on the surface. In ducks, especially mallard ducks, when it's breeding season, their hormones are so high they make teenagers look like old spinsters. And they can become very aggressive. So in mallards, the males will chase a female and then forcibly mate with her. This sounds bad to us, but what it's doing is it proves to the female that he is fit and he will likely produce fit offspring because he has to catch her and he has to pin her down. Once they've mated, the male will protect and feed the female while she's in the process of laying eggs. So he'll bring her food. Once she's done laying eggs, and a female mallard can lay 12 eggs, the male departs and the rest of raising the chicks is up to the female. While the male mallard's hormones are raging, they will often display a diverse range of behaviors related to mating. So the first one is what we politely call extra pair copulations. Copulations, that's sex with the intent of producing offspring. So that's penis in these birds, cloaca. Well, they do have vaginas. The female ducks do have vaginas, sorry. So that's penis and vagina, basically. Extra pair means with somebody who's not their monogamous partner. This is common in all birds. Even birds that don't have penises have a lot of extra pair matings going on. Most birds that don't have penis, both the male and the female raise the chicks. So there's a lot of diversity going on in breeding here. Most clutches in ducks will have multiple fathers. And if there aren't enough females around, the guys, homosexual behavior, very common in male mallards. And disturbingly, even necrophilia. You guys know what necrophilia is? Okay.
Do we have any idea why they engage in that?
The hormones are just raging. The times that this has been seen in ducks, there have been a couple of instances where it's been observed. And in both cases, the male was chasing another duck. In at least one of those cases, it was another male duck. The male duck in the duck in the lead, in one case, hit a window and broke his neck. In the other case, it was hit by a car. So they were doing the foreplay, and their partner dies. And they're just frustrated and going for it anyway.
So we don't have any evidence of them like coming across a dead duck.
We don't. That doesn't mean it doesn't happen.
Yeah.
Okay. The female ducks and the female ratites do have vaginas, so they do have an internal structure beyond the cloaca. And in the ducks, the vagina is corkscrewed. So it's kind of the same shape, except the corkscrew goes the opposite direction. Which means, bye Heather, the female can reduce unwanted breeding because she has to be in the mood and she has to allow the male, she has to help the male get that corkscrew penis into her oppositely twisted vagina. After breeding season, especially during migration, all of these structures shrink. Bird hormone levels go down. This wild, weird behavior that we see in these mallards declines. We know a lot about mallards because they're very common and they've been domesticated. So we've had lots of people observing mallards. There was one other thing I was going to say here that isn't in my notes. It just flashed through my head. And it's completely gone. Okay. Ooh, queer ducks and other animals. Oh, that sounds interesting. I may have to check that one out.
Yeah, it's about the history of the science of how we look at and categorize and understand homosexual behavior in animals and sort of what that tells us about how we think about it in humans and different ways that we've sort of ignored it in science versus not.
Yeah, that sounds interesting. I'm typing. In the comments, a title of a book. If you're into different ways that animals mate and reproduce and everything, Dr. Tatiana's Sex Guide to All Creatures by Olivia Judson. Very entertaining. It's written as kind of like an advice column. So it's very entertaining, but you get to learn about, you know, all kinds of different ways that sex goes on in the animal world. Okay, any questions on reproduction?
Why do birds? I just feel like, oh my God, that's like their actual anatomy is just so complex.
I don't know that you would say it's complex, but it's very different than
different.
ours. Yeah. Well, birds are more related to reptiles than they are to us. They're not related to us very much at all. It's been whew, a long, long time since we separated from them. So we just evolved differently. Okay. Our next topic are the senses. And so what I'm going to do now is I'm going to send you into breakout groups. And what I want you to do in your breakout groups, I have to stop share, right? Is answer the following two questions. How many senses do humans have? And name all of the senses that you can think of. And I will give you a hint. If you think humans only have 5 senses, you're off. So I'm going to give you guys 5 minutes to talk about that in the breakout groups and come back and everybody's going to go, I only learned 5. Okay, welcome back. So, how many senses do you have? Kinley, go ahead.
We said 12, but I looked it up and it said like 22.
Well, good. I'm glad that you guys are getting beyond the 5. Maddie, go ahead.
Yeah, I mean, I didn't remember all of them, but I did remember like a couple. Is it okay if I say the ones I remember?
Absolutely.
I mean, other than like our 5 like obvious ones like touch, sight, smell, whatever. I remembered we had a sense of time, direction, temperature, pain, balance. There was one more that I like knew, but I can't remember
Okay,
anymore.
that's good. Anybody else want to chime in?
Look, Anna, it is with an I. We were trying to figure out how to spell proprioception.
Ah,
We weren't sure whether we were doing bird or human. We were pretty sure we were doing human.
okay.
But either way, connected to proprioception, you have kinesthetic.
Okay. Yep.
We had humor.
Can you also do fear?
I'm not sure that we would consider humor and fear. We say sense of fear and sense of humor, but I don't think we would consider them senses. Would we refer to when we're talking about the ways to
Perceive
detect the
the
world
world.
around us, perceive the world around us? Yep.
I kept
We
coming
also
back.
had rhythm.
Oh,
I think rhythm is also going to be in that category. We call it a sense, but it's not a way to detect the world around us. Ronit, I think you got interrupted there.
I kept coming back to this idea of like danger, like not this sort of what I suppose we term like sixth sense,
Hmm,
where there's like something is off.
right.
So maybe like your fight or flight.
Yeah, that's usually
Response.
related to either hearing or smelling something nearby that it's not significant enough that you notice it directly.
So it's more in the processing of the sensory information rather than the sensory information.
Yes, that's a good way to put it. Yes. Maddie, did I see your hand up? Did you take your hand back down?
No, so just onto the rhythm one. I mean I personally would consider it a sense. I mean I've done theater for years and some people just like simply do not have it.
Mhm.
And it's definitely like a way that you're perceiving it. And it's really difficult to be taught.
Okay.
So that's why I would consider rhythm like an actual sense. But I mean scientifically it might just not be, and that just might be the way that I'm perceiving the way that people are doing that. But yeah.
Yeah, when we're using senses in the scientific sense, we're talking about ways of perceiving the world. I can see where you might put rhythm in there, but I think that rhythm and humor are neurological processes specifically. So they're in the brain rather than in some part of the body. Anyway, that's good. Did anybody know of any senses that are found in other organisms that are not found in humans?
What about sense of magnetic fields?
Magnetoreception, yep.
I just looked it up, and rhythm falls under the sense of anticipation.
Okay, okay. That's interesting. We are going to talk about magnetoreception. And how that's related to the sense of direction. Any others that you can think of?
Would you put like? I was gonna say something about like waves. Would that be magnetic reception?
Well, hearing involves waves, sight involves waves, magnetoreception. I'm
I'm
not sure.
talking about like seeing different things though, for sight.
Yeah, sight is depends on wavelengths of light.
Wouldn't you put infrared under sight?
It's one of those things that's kind of on the borderline. It's more detecting temperature at a distance. We call that infrared radiation. I don't think that's a form of light, but I think it's like just there on the line between what we consider light and what we consider other wavelengths. I mean, when we look at the electromagnetic spectrum, oh my God, there's a big word for us. Electricity, magnetism, radiation, vision, hearing, these are all on a spectrum. And we just divide it up into categories. Does that make sense? Do I need to find that? Let's see.
I've definitely always learned that infrared was a type of light, just not visible to humans. How are they receiving that information?
Hang on a sec.
Through military, right?
Infrared sensing, thermal radiation. That's in snakes there.
The body, yeah.
So we see, we have devices that show it this way, but I don't think that, let me look at the spectrum. Maddie, go ahead.
Yeah, I mean, in snakes, they have specific heat sensing pits.
Mhm.
Specifically pythons and pit vipers are the ones that can, except there are two species of pythons that weirdly don't have them, womas and blackheads. But yeah, so I don't think that that would really relate to any other animal because they do have that specific pit, the heat sensing pits.
Mhm.
So I don't think that, like, if you were to look up like sense of infrared light, I like looking at specifically if you were to look at like the ones with snakes, that probably wouldn't be very helpful.
Yeah.
Because they have that specific like evolved body feature.
Yeah, and that's common in animals that can detect infrared radiation.
Oh, okay.
Not necessarily the pits, but having a special structure for it.
Mhm.
So here is electromagnetic radiation, and you can see radio waves, television waves are kind of down here. These having a very long wavelength. Microwaves, slightly shorter, infrared, slightly shorter, visible light, then ultraviolet, then X-rays, then gamma rays. So the separations between these categories are pretty arbitrary. the difference between visible light and ultraviolet light really is what can we see. Same thing here on the infrared side. So would it be part of vision? Like Daniel and Maddie both mentioned, it doesn't use the eye. So I think we would call it a different sense.
In birds as well, they have a different structure that receives that information.
Birds don't necessarily have an ability to see in infrared. I
I
was
know
just
a lot of birds can see in ultraviolet. Would that go under a separate sense as well? Whereas,
we're going to put it with sight because they use basically they use their eye to see that. And so that's why we're going to clump that one into sight. Okay. So let's get into this. First off, birds can see better than you. An ornithologist named Oner Gunterkun, that's a name for you, right? Woo! Probably German or somewhere in that part of Europe, referred to pigeons as two eyes with wings. So what makes bird vision special? First off, their eyes are larger than mammal-sized eyes, if the equivalently sized mammals' eyes. So they're bigger compared to their body than what we have in mammals. They have a special adaptation that allows them to change the shape of the lens. So the lens is a structure towards the front of the eye. So this is the front of the eye. The lens is a structure towards the front, and we have muscles that allow us to change the shape of the lens. And that focuses images on the back of our eye, on this back of our eye, which is called the retina. So birds have a special adaptation that allows them to change that faster than we can. So they can focus quicker than mammals can focus. Flight adaptation. If you're flying, you've got to be able to change your focus very, very quickly because you're moving pretty quick. The eye is a different shape than mammals. The mammal eye is more rounded, and bird eyes are more flat front to back. There's less distance front to back. This increases the depth of focus. So what this means is, if you're looking at your computer screen, and like my monitor is, there's a window behind the monitor, and so I can see outside the window, and there's a tree across the street. The tree is not in focus. The plants in my garden on this side are not in focus. So depth of field is how much of an area we can focus on at the same time. And birds can see in focus a larger depth than we can. So they might be able to see the monitor in focus, the desk in focus, the curtains on the window in focus. They can see a lot more than I can. The lens of birds is pushed forward. So this is roughly where the lens in our eyes is, but reptiles, the lens is further back. So having the lens further forward increases the size of the image that's projected on the retina, which means they can see sharply at longer distances, or they can see small objects at longer distances. The retina, the back of the eye, has a lot of receptors. Receptor is just a nice general term for something that receives a signal. And the receptors of the eye are cells, and they are divided into cones and rods. Birds of prey, the diurnal, the day active birds of prey, have a higher density of receptors on the retina than other birds. So they can see a much clearer image. They've just got a lot more information going into the brain. When we talk about nocturnal predators like the owls, remember their sclerotic ring is tubular, and that maximizes visibility in low light conditions. They also do not have as many cones, so they don't have good color vision. The rods are good for low light conditions, but they cannot detect color. Seabirds like terns, gulls, and albatross have oil droplets on these rods and cones of their retina. And these oil droplets help to improve vision at a distance, especially in hazy conditions. Do not ask me how this works because I don't understand it. But if the conditions have a lot of humidity or fog or low-lying clouds, they can see through that fog much better than we can. This structure is also kind of weird. I'm not going to ask you about this, but because it's here in the middle of the image, this seems to be involved in delivering nutrients to the cells at the back of the eye and dealing with pH issues. It helps regulate the pH on the inside of the eye. So, ultraviolet light. Birds can see in ultraviolet light. So while we see a bird that looks kind of like this, if we shine UV light on this bird, we can see that it's going to reflect in 1, 2, 3 colors that we cannot see. It's not going to exactly look like this. We can't tell. We can't see ultraviolet light, so we don't know what it looks like. And there's no way to represent it that we can detect it. So this is just, kind of a false color look at it. So I was talking about those cone cells. In humans, we have 3 types of cone cells. Each one detects light at slightly different wavelengths. And it's the combination of how many of the different cones are active that cause all of the myriad of different colors that we can see. Birds have 4 types. So they can see a lot more colors than we can into the UV range. Since birds can see in ultraviolet, this can be used to distinguish the sexes. When we put UV light detectors on birds' feathers, we often see that the males and females appear different. Even though we can't tell the difference, they are seeing obvious different markings. Color is often used to demonstrate fitness. So if we think of cardinals, bright red birds, a male that is that bright red has to be extremely fit to be able to survive in the wild with that kind of color. Oof, I just looked at the clock. Okay, we're just going to finish up this page and then we'll be done for the day. It's also helpful in feeding strategies. For example, I've mentioned this before, there's a molecule in rodents that shows up as UV. So that's helpful for bird of prey tracking down rodents. Okay. We're not done with vision, but that's the ultraviolet light part. Are there any questions here before we wrap up for the day? Everybody got something interesting to talk about at the dinner table tonight? Like, oh, I don't know, duck penises?
Oh, definitely.
Yeah.
Oh, so Laura, what did you do today? Oh, I talked about duck penises.
Okay. In that case, I'll see you guys next time. Bye.